Let us establish that this is uncountable. We know that the set of rational numbers is countable. Where mn has no factor in common. It is infinite, but it is countable. And we have defined aleph null to be the number to which it extended to. But this interval is uncountable. How can we establish that? Let us assume to the contrary that all the numbers in this interval may be denoted as x1, x2, xn, xn plus 1 dot dot dot. If we assume that all the real numbers in this bounded interval is countable, we will be able to enumerate them like this. This is a scheme of enumeration. So we assume that it is not countable and I is enumerable, and this is the scheme of enumeration. So all the numbers in this interval is listed. Now we use the nested interval property. Let us construct a sequence of nested interval such that we first construct I1 out of this I such that x1 is not in I. Since I contains all these points, so I1 will be a proper subset of I. Clear? So x1 is not in I1. And next, from I1, we delete x2 and construct I2 such that x2 is not in I2. So obviously, I2 will be contained in I1, which is contained in I. And we move on like this to reach In such that xn is not in In, and this In will obviously be contained in In minus 1. So you have this sequence of nested intervals I1, I2, I3 dot 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 In, all of which are proper subsets of I, and they are a sequence of nested intervals. Means I2 is enclosed in I1, I1 is enclosed in I, I3 is enclosed in I2, In is enclosed in In minus 1. So due to the nested interval property using Bolzano-Weierstrass theorem, we have that this sequence of nested interval converges to a point xi of I. So this xi is a point in I. So all the points in I are enumerated like this. So xn will be equal to xi at least for some n . But since this is a limit point, due to the nested interval property, this will be in each and every interval because it will be in the intersection of In. But xn is not in In for any n equal to 1, n equal to 2, n equal to 3. So xn will not be in In for any n. So how can xn be equal to xi? So there is a contradiction of this assumption that all the values of I may be enumerated like this. which shows that this is uncountable. We have proved it with a contradiction. We first assumed that it is enumerated and then shown that using Bolzano-Weierstrass theorem we can construct a sequence of nested interval and the limit point of convergence is not in any of these intervals.